Hello everyone, good evening. Let me share my screen also. Please share. So you would be seeing multiple tiles on my screen like tile like windows. Let me confirm with you the same. Yes and no. Let me post a code. Yes, it's 100% yes. Okay guys, then we will continue. Yesterday we have been talking about cloud computing and different service models, why we need cloud computing, and we have talked about IoT, we have talked about big data analytics and how cloud has been a central point of all these things, and we have also talked about different analytical platforms offered by AWS and Azure clouds, and we have seen into AWS SageMaker, a walkthrough to AWS SageMaker. And let us start with a quick recap so that you all can be on the same page. I'll say cloud recap. We have started off with introduction to cloud computing. And there we have talked about why we need cloud actually. And there are various reasons organizations when they have their own data centers. So we have talked about data centers. Data centers are nothing but when you maintain servers on premises, it's called as data centers versus cloud. So when you move on your servers to cloud, not only servers, the applications running on the servers, the storage in the servers, when you move on to the cloud, it adds more flexibility. That means you can scale up your services, you can scale down your services, and also cloud reduces your costs, operational costs, and capex, opex. We have discussed capital expenditure and operational expenditure will come down. That's one thing, and a lot of other issues like server sprawl, where you might be spending a lot of money. The organization is spending a lot of money and assigning servers, buying and setting up the servers, but they are underutilized. When you move on to cloud, all such issues, upgrading your systems, maintaining your licenses, maintaining the software, hiring the resources who have the skill set to maintain and work upon with these hardware and software as well, all of these things will be um, eliminated, and businesses can actually focus on their business. That is, in short, uh, cloud offers you. As I said, it's on utility basis. You can say it's computing as a utility, right? You can call cloud computing as computing as a utility, like how we use electricity, like how we use water and pay bills, but we don't bother about maintaining them actually, how they are set up, and if something goes wrong, we no need to bother about fix it, all such things. In the same way, we are getting computing power as a service, and we don't know where this actually computing resources are there and from where we are using, where they are physically located. Of course, they share that information that they are located in some region and availability zone like that, but we don't see them. That's why the name, it has been creatively named as cloud. We are using the resources, but we don't know actually where it is. So that's about cloud. And there is a NIST model of cloud. So NIST is the organization which will set up standards to technology, all the technologies, and it has said that a someone who is coming up and offering you these computing services as a utility, they should have some characteristics. And what are these characteristics? Broad network. So it has to be globally available. Cloud is a global platform, so it should provide the broad network, on-demand services. I need objects or storage, so cloud should provide that. I need to able to create virtual machines. Cloud should provide that service. I need databases. So these are on demand on the market. So it should provide those on-demand services and at metered price. That means cloud should communicate with us the upfront costs even before actually we are charged. We should be able to know like what should be our what actually for what services we are going to get charged, so that we can maintain our services according to our budget or organization's budget, right? Metered price, and of course it works on economy scale. Economy scale means when you play with like pretty big uh, things, like cloud has huge set of servers. It has a huge storage space, and when it have such a amount of huge space capacity and etc., and you can get them actually at pretty cheaper prices compared to having on yours, like right, when you have your own storage, own server on premises on your data center, you have to pay for licenses, electricity, HVAC costs, heating, ventilation, and air conditioning costs, and the storage will be limited. You cannot expand it like whenever you want within a minutes. When you go for cloud, which works on economies of scale, it's already in a huge scale there. So you get it for cheaper prices, and you can scale it up. When you don't want, you can scale it down. When you want to terminate, you can stop paying for the service, right? And this is called as resource pooling. So these are some characteristics of cloud, and again it has defined the different types of clouds. Let me add a tail here. So different types of clouds, right? We have public clouds where resources are shared among the users. See, I have a subscription with AWS, and you might be also having this subscription with AWS, and maybe we both belong to same region. We have selected the same region. We might be using the same shared resources of AWS there. So that is public. And if you don't want, you can opt for private cloud. Organizations, they don't want to share the hardware resources for some reason, security and privacy concerns, they can go and request public cloud vendors to keep that hardware dedicated to them. And of course, it might be expensive when compared to the public cloud resources. And a hybrid is a mix of both. And then we have community, which are domain specific clouds. And NIST then defined different types of services. Here is typo. Okay. And NIST has told different types of services offered by the cloud, service models offered by cloud. As I said, cloud is nothing but computing as a utility. And what computing means actually? Computing means whatever you can do on your computer, you're going to do on the cloud. And not only that, lot more. The powerful computers are there, and we call them as servers. And it's IaaS. Suppose you just need a bare metal machine with operating system, or containers, empty containers where you can dump your own code, then that kind of service are provided by cloud, and we call them as infrastructure as a service. And there is software as a service, so let's say platform as a service next. And rather than working up everything, maintaining everything on that bare metal machine, you need a platform where you can play around. You can bother about your application and your data only. You don't need to bother about how they are set up, how to maintain, and how to upgrade them. Then just go for platform as a service. So there are the learning platforms, analytical platforms, databases, even the web developer, web hosting platforms where you can just go and code, start building your website. All these things are platform as a service. And then we have SaaS, software as a service. We talked about it. So when you are using something via your browser and internet, you can call it as a software as a service. You are getting it as software as a service, right? And we have talked about all of these things, and then we have moved on and talked about some emerging technologies. One is IoT or IIoT. As I said, IoT is a generic term which refers to all the domains related to consumer, healthcare, industries, social, and IIoT is specific to industries. You can say IoT rather than that, and we have talked about big data in a high level. We just defined, looked into the definitions of IoT, big data, and data analytics or data science. So what actually they mean is IoT is nothing but you can collect data using sensors. You can embed that sensors in almost everywhere, because today we have miniatured hardware, miniature sensors, and we are getting sensors in the size of a dust particle, and we are getting microcontrollers like very very miniature ones, and we can integrate these sensors almost in everything, and we can get data. So why we need to get data? What's a big deal in getting some levels of temperature, vibrations from machines, or from oil leakages in the pipelines? So why actually we need it? So we might not bother about it, but industries, if they can save, you say at least 1% of data when they count a year, if they are able to save 1% of loss, that would be like $1 million. They can save like $1 million per hour. So industries are keen in utilizing the data, and how? Using IoT again. You get data from the environment or from the object, measure it through the sensors, and the data which is generated, we call it as big data because it's humongous. And then we need tools to handle this big data, to like organize, to stream them, to analyze them in real time. We need tools, and then further it has to be analyzed. So our ultimate goal is to analyze and get benefit of this data. Say I have fuel leakages there, I can immediately trace out and fix it. My prediction model, which gets data from the IoT sensors, will tell me why actually this vibration level is high due to overload, or is there any underlying health condition is not so good inside the machinery. So for all these benefits, these have become the emerging technologies today in the market, and we have a central point connecting all these technologies, that is cloud. Why? Because cloud offers you computing as a service, computing power, and again, say computing power means your CPU and RAM. If you want to increase your laptops, or you have bought a very high-end computer, and for some reason the computer has been a source for different applications and you need more computing power, you cannot expand it. And that's not the scenario with cloud. If you have a virtual machine on the cloud, you can increase its capacity and you can have more computers virtually. It offers you computing power, it offers you storage, and further you can have your own secure networks. And then it also offers analytical platforms, analytics. So, having said this, cloud offers you all of these things, and that's why it has become a central point for all of these technologies. You stream your data into cloud, and there are tools already to handle this data, to store this data, and there are platforms, data analytical platforms, to work upon this data. And your job has become easier and everything is at one place, and you can build up your solution there and benefit, get a solution for whatever might be the problem it is. Suppose a leakage is a problem, you can generate a alerts predicting it. If it is something, if it is a consumer electronics, we have a best example, smartwatches, and we know how they are working, and we have a solution for every problem. We can automate the things, and the central point of all this discussion is cloud. So in short, that's what we have talked in our yesterday's session. And let me ask you guys, any doubts? Okay, no. Okay, around 90% says no doubts. If you have any doubt, you can type in the chat box. And poll, page not clear. Yes. Yes, guys, is my screen not clear? It would be little blurry, but it's too much. Page not clear. It's a actual issue with webinar jam. It will be little blurry. And yesterday we have been talking about AWS. So before that, yeah, first we'll go to our AWS, Amazon.com, and I'll go to my account, AWS Management Console. Authentication failed. Okay. Yeah, so in short, what cloud offers you, what we have talked about, it offers you compute services and here or there, and it offers you storage here or there, and again it offers you databases, and here it is if you want to migrate, if you means your organization, if it want to migrate stuff, entire things, storage, servers, databases, everything to cloud, yes, migration and transfer plans are there, and there are options available for you to maintain your own network, networking and content delivery. Like your website is accessible globally, and you can have your private networks again. These things are services are related to that, and you have a platform for coding. There is a code star, code build, all of these things are there, Cloud9. Yeah, and you have again analytics. So right, cloud offers one more thing, analytics as a service, and machine learning is there here, blockchain, and a lot of tools for analytics to visualize your data and to stream your data, analyze it in real time. We have all of these things. And somewhere here, Internet of Things, right? So connecting devices to your cloud is has been made so simple with these platforms. So you just register your device here. You will get a password kind of a thing. We call it as authentication, encrypted key or some certificate, and use it on your device. Your device will send data to cloud, and you can play around there in the cloud, and you no need to bother about rest of the things. Configuring your devices is simple. You can connect, even though thousands of devices are there, you connect them to cloud and play around with the data on the cloud, and that's it. Right, you no need to actually bother about how to configure these devices to each and every service. Just connect it to cloud, and that's what Internet of Things allows you to do. Game development, and you have a containers, elastic containers again here, which again these comes under infrastructure as a service. Your containers are nothing but some virtual things where you can work on with your codes, etc. We call them as modules. You can assume that them like virtual machines without operating system. You can access them virtually, work on them with virtually. Those are containers. And here under machine learning, the first one is Amazon SageMaker. We have talked about it. We will briefly discuss about it. Amazon SageMaker and how it works. And here you can have your notebook instances. Again, instances is nothing but Amazon calls everything as an instance. Like if you create a virtual machine, it's called as EC2 instance, Elastic Cloud Compute. If you have a storage container created, it's called as S3 instance, it's bucket or S3 instance. So something which is running on up and running on the AWS side, it calls it as an instance. Instance is something like which is happening maybe in the real time like that. So like that, you can have a notebook instance. Notebook instance is nothing but the environment where you work on up with your machine learning. And what is machine learning? Let me quickly walk through that also. So this is Azure Machine Learning Model Workflow. So what we discussed yesterday is machine learning is something where you build a model through your programming, and we call them as algorithms. What these algorithms will do is they will teach your machine. Like we humans, when we are newborn, we don't know anything, and then we grow. What we will do is we capture things around us through our sensory system, and this is our data set. And through our data set, we start learning things. And the same thing we can analogy apply to machines also. But here we have to do all that work. It's not like we humans can learn ourselves. Our brain will keep all the data set, and it will try to map whenever a new things which you encounter, new environments, things or experiences, your brain will always try to map to the previous data set, which is your past, past life. In the same way, this analogy you apply to machines also, but the thing here is you build that data set, and you through your algorithms you tell that how the machine has to map with the data set and the real-time data coming to it. And again, there are different kinds of machine learning, uh, reinforcement machine learning. All these things are there. Trained, untrained, all these things are there. So we don't go into much deeper. So this is machine learning and high level. And cloud offers you platforms where you readily can train your machine, validate, and deploy and monitor. So in short, what you'll do is you'll train your machine and you will have a data, and this data set, as I said, the data will be available with your machine so that it will map to the new set of things coming to it. And this data is classified into two categories: training data and test data. So what is training data? Teaching your machine. As I said, a group of images of cats is there with your machine, and again your machine has to be tested, right? So there will be a test data which can be like input given to your machine, and through various test data your machine will learn. And then you'll build a model and you'll validate your model by providing the test data, and this entire setup is ready. Once it's ready, when a new data is given to machine, it will predict. So let us take an example and understand. Again, we will take an example related to industries. We say prediction, like predictive model of an breakdown. Whether machine is going to break down or not, we need to predict it. So for this, a data scientist, he had gone to cloud with the training data set, and this training data set is previous values of healthy machine and unhealthy machines: vibration, temperature, stress, strain, all of such things of a healthy machine and unhealthy machine. This is training data, and once he has the training data, he has started building a model. What all this model has to do is it has to map the new values coming in, the new vibration, pressure, stress, strain values coming to it. It has to map it to the values available in training data, and it comes to a conclusion whether machine is going to break down or not. And in this process, he should also test it. That's why he maintains a test data set and validates the model. And once it's ready, once the validation is up to the mark, so from conceptualization to production, now machine learning is a final stage, ready to go into the production environment. And the result it makes the predictions in real time whether machine actually breaks down or not. So not only here, the recommendations which you see online when you are purchasing something, um, that portal, that e-commerce portal will give you recommendations, other products, similar products, right? Even with movies, when you are watching a movie in any platform like Netflix or Amazon Prime, so they will recommend you. So if it is like a fictional movie or a horror movie, next you will get recommendations, right? And how actually all of these things are happening? Machine learning again. There is machine learning behind it. Your new search is like a new data to that machine learning backend, and it will map to already data available. So your new data will be mapped. Suppose you watched a horror movie, and that is the new data for that machine learning, and it maps with the training data set, that is horror data set. And what are all there in that data set? That movies will be recommended for you. Recommendation engines, fraud detection, all these things. Again, predictive models, all these things. Machine learning is behind it, and this is again Azure Machine Learning Service. We'll come back to it, and let me go back to AWS. Yeah. Anyway, we have talked about it. What are all these things, right? And first you have to train your model, and through a work environment called instance, you train. Again, there are training jobs available and hyperparameters for tuning your jobs. So once you train your job, it might not be perfect, right? You should provide hyperparameters. These suppose my machine learning model has to rate a movie, or it has to recommend a movie. I will give some parameters to choose, like what type of movie it is, genre, ratings, location, language. These are the things available in my training job, but as the machine learning moves on, keeps on working, I need it to upgrade by itself. Through for that, we call such thing as tuning. By setting an hyperparameters, we can say uh, machine itself can tune, upgrade itself. And here we have looked into what are notebook instances, process jobs, and other things. So this is one platform which is used for machine learning, and again Amazon Auto ML SageMaker is also there. And not only providing a platform, the templates are also available for you. Lot of algorithms are available for us. You can just select and play around according to your requirements. So that is about AWS and the analytical platform provided by AWS, SageMaker, right? And then let's also look into Microsoft Azure, and this is how it looks like. And here we have an option called create a resource, and this is creatively named as Azure Marketplace, since they are selling their services here, displaying all of services, their services. It's called as Azure Marketplace. And again, they are segmented out here like AI plus machine learning, analytics, blockchain, compute, containers, etc. Again, storage, software as a service, and here there is Internet of Things, and all of these things are there for Internet of Things. Again, networking, like you can correlate with these clouds, only the terms are different. Here again you have a networking, and you have containers, databases, again compute, again where you can create a virtual machine. You have a Kubernetes service here, and the databases, again developer tools, all of these things are there. And here is the one place where you can search in Azure Marketplace, or you can just search directly here on this search bar. And also there are some few options here on this tab. So this is like a home page icon, and here you can see what are all the services, favorites, dashboard. So the services which are already created in your account will be there here on the dashboard, and you can pin this dashboard. Moving on to right corner, right section, here this is called as Cloud Shell. So the terminal, oh, I have closed it. Let me say, I'll say bash only. Oh, it's asking me to create a storage, since this is a new account. So you should create a storage, and you will be charged very minimal amount for having this for Cloud Shell. Cloud Shell is nothing but a terminal where you can view all the updates and other things happening on the cloud. And then here it is like uh, your directory plus subscription details, and then you have notifications window here when you are creating something, or if Azure want to communicate any updates or other things, they will be here, and it's intuitive again. And the portal settings, and here it is help bar, feedback, and then if you want to switch around your directories or change some settings, you can do it here. And here Azure again, it offers something called as ML Studio, Machine Learning Studio. Let's say machine learning. Say machine learning studio classic workspaces. Let me type in as machine learning here. So we got these searches. So why we are talking about machine learning? When coming to analytics, we have a lot of things under analytics. It's not only machine learning. Your stream engines, the data mining tools, and then machine learning tools. All these comes under your machine learning. So data analytics is an interdisciplinary thing. Your data mining, machine learning, analytics, all these comes under this thing. And for machine learning, we have this machine learning studio. Let us go to machine learning studio workspaces. Like we have AWS SageMaker. Here we have Machine Learning Studio workspaces, and I already have created one studio here, 360 Studio, and let me create another one. Add. I'll call this workspace as DigiTMG ML Studio, and subscription is pay as you go. And if you are new to Microsoft Azure, newly creating a Microsoft Azure account, so it will provide all of its services free for 1 month. 30 days free trial is available with Microsoft Azure for the first time. And again, it measures your services in the form of credits. I think around 30,000 credits. 13,000 rupees worth credits will be given to you, and you can utilize them within a month of time. And resource group. So here how Azure works is, it asks you to first create a resource group for anything, whether it's a storage or computing or analytics. It first asks you to create a resource group. Suppose you're working on up with some application, you're building up with an application. You might be creating a storage database, a machine learning thing workspace like this, and you can put all of them under one roof, and it's called as resource group. Like you're telling that they all belong to the same thing, one resource group. And here I already have one resource group. I'll go with it. And then location, again, like AWS is globally available, and they have created that interactive portal saying about their regions. And the same thing here in Azure also. These are all the regions they are available, and of course they are not mentioned like specific city names. You can choose the nearest region. Like we belong to Southeast Asia, so Southeast Asia. And storage account, I'll say use existing, because since I'm a pay as you go, I don't want to create one more one. I already have a DigiTMG storage account here. And workspace pricing is standard only. And web service plan, I'll just go and create a new. And here, okay, dev test standard is not available for me. Why? Because I have already used one and it's free if you see. Let me close this. So only the difference is the number of computing hours, transaction. So we are building a machine learning model here. And with the compute hours and the transaction, the pricing of different standards will get increased. And for testing, they have provided this dev test standard, but it's not available for me because I already have one. And the max limit is only one. Let me go back and go into this one only. So once you have created your ML Studio, it will appear like this. This is my ML Studio here. I'll add a directory again. Let me go back. This is my resource group, and here I can click here to add tags, label storage, and etc. And here I will be able to create a project. So export template logs. Okay, here it is. Let me go back once. And here I have this resource group, and when I click on it, here it is. Here it is my storage account and my studio plan, my 360 studio. All these things are there. Let me go into this workspace. Yeah, and here I can see the number of hours it's working, all of those things. Okay. So build and deploy solutions, leverage the community. Let us click on this build and deploy solutions. So here it takes you to another page, and I'll go to my experiments. This is your ML workspace. Let's say not now. And let us create a new experiment. And here now this is the workspace where you can create your ML algorithm. And here you have all these options. There are data sets. These are projects and experiments, web services, data sets. Again, you can have your own data sets. You can upload your own data sets, and you have your samples here. And all of these are samples where you can work on. Uh, right? There are movie tweets, movie rating samples, airport codes data set. So all these are samples of data sets, and there are trained models again here and settings. And let me go back to experiments and create a new blank experiment, and I'll call. Oh, again it has gone through this one's my experiments. I can drag and drop things here. I'll go to my save dataset, samples, and I will type in like for movie. So movie recommendation engine, let's say movie. Let's say movie ratings. Drag and drop here, and then I'll search for project. See, remember guys, so this is a data set, and what we have discussed and how machine learning works. Let me go back here. So this is my data set, movie ratings, which I have drag and drop on that page. Next, you have to train it, and you should divide your data set into training data and test data. And then you have to build a model, validate it. And then on your data set here is a recommendation engine will recommend movies for the users based on their past history. Right, so our data set now is movie ratings, and I'm going to split it into training data and test data, and I'm going to build a model and validate it. So let us just walk through, understand the analogy. That's it. We're not going to discuss much about machine learning. Yeah, again going back here, say movie ratings, and then where it is my manipulation, I'll call a drag and drop this, select columns in dataset and launch column selector. On what basis you can select the columns within your dataset? You can go with rule or by name. Anyway, all columns. I'll say include all the columns. Please enter the column name. Say we'll go for exclude then. Okay, why it's not giving this? I have to map it. Okay, and launch column selector. And here it is, user ID, movie ID, rating, timestamp, all these things are there. Okay, let me move all of these things. Or if you want to write any rule or with rules, all columns excluding or including, you can give here, excluding timestamp. I want all of these things. And click on the tick button and yes. Now movie ratings is my data set and I have chosen few columns in it or all the columns in it, and then I'll split this data into two things like mentioned here again, into training data and test data. Let me go back here. I'll type in a split data. Okay, and the split data of movie ratings again here into two things. Dataset 1 might be my training and dataset 2 will be like my testing. And then I'll say look for train because training dataset. There it is, training anomaly. I'll say train matchbox recommendation. Again, these are different models, like how you train your machine learning and training, right? And then testing, like evaluation, you can say, or a score, right? And a score matchbox recommendation. These two things are there. And then evaluate. You have to evaluate your mission. So I'll say evaluate recommender here. So these are the things needed for my machine learning model. So movie ratings is my data set. I have selected few columns in it. Now I'm going to split it into two things. And one I will give to split data. And the second I'll give to my score matchbox recommendation thing. And then I will select my trained because this has to be mapped to this. Again, for evaluating this thing, again my split data will be given to this part and score match box recommender also. So this is as simple as that. So once you understood, of course, if you work it on up with from conceptualization to production, the entire machine learning. So all of these steps has to be taken by you, and you have to develop these things. And here, what this platform called Machine Learning Studio does is it allows you to just drag and drop, and it's as simple as that, right? And you have splitted your model again into two things. Dataset 1 and 2, which is your training and testing. See here when I split, and again you can decide like how you want to divide your data set, and here we have divided into half, or you can mention some terminology here, say, let's say only 70% is data set 1 and 30% is data set 2. Like that you can customize it. So we will keep it 0.5 as is. And coming to train matchbox recommendation, the number of traits, number of recommendation, and number of sets for training batches. Again, uh, we will say 5 data sets for recommendation and 5 sets for training batch. And your score matchbox, again we will leave this also as is. And then your evaluate recommender. So how it evaluates your recommender? It will check 2 items with the say user with the 2 items of user data. When it matches, it recommends. Suppose uh, the journal of the movie and some ID or something language. So any 2 items, if it's match, it's going to recommend it. So these are the things, and then I'll check for another data set, movie titles, right? It has to tell the movie titles, and let us visualize what these movie ratings have. So when I click on this, I have an option to visualize. It has user ID, movie ID, rating, timestamp. All these things are there. If you see, and rating is from 0 to 10, movie ID, user ID, and the other things are there here. And then titles. So let us see what this data set has. Again, it has movie ID and movie name. And here I will drag and drop one more thing called as metadata for manipulation. And click on metadata, launch column selector. Here again you have to select the items. Let us drag and drop all of these things. And then now I have to join this movie ratings to movie titles. I'll say join, join data, join data here. Join the metadata with, say I'll join from here. Right? So let's say here inner join. Um, Left outer join, full outer join. Let's say inner join only. Launch column selector. Again here all columns. Let me check here once. All columns. We have chosen these two things. Delete. Why it's not coming here? Maybe. But outer join. Okay, I don't know the reason I need to join this core match box to the join data. Anyway, I'll add one more join data here and add this to this. Launch column selector. No columns. So that has been wrong. Movie titles. So here it has to get from the score match box. Or launch column selector. No columns. Okay, let me join dataset 1 to here. Okay. Okay, so let us take these two, but not to join. Delete and delete this. I'll try to join metadata with this. Okay, yeah. So here, so what it has to do is visualize. So here I have user ID, movie ID, rating, timestamp, everything. And here I should also get two more things: the recommendation, the movie title, and the recommended movie for that movie from the data set. So here the metadata, I cannot visualize this. Okay. So that's about Azure Machine Learning Studio. So here you can, let me take this. Delete. So this is just drag and drop this. So if everything has been fine, then we would might have been seen that recommendation engine. Okay, and then moving on to IBM. I'll go to my IBM. Just a minute, guys. Let me check. Login. Okay, this is my IBM. My IBM portal. Say launch. And the best thing with IBM is they offer you free services and no need of your credit card details and other things. So these surveys with certain, of course, only free or only made available for us since we are creating a free account. And here is the catalog where all the services will be displayed there. You can search in this catalog and Watson Studio, Watson Assistant, visual recognition, speech to text, machine learning, text to speech. So all these things are available. And the best part of IBM is if you are looking to launch a chat box kind of a thing for your web service or any other thing. If you need to develop a chat box, it's easy. Say it's an AI driven chat box. A platform is provided readily available for us. See this text to speech, speech to text, and visual recognition. All these things are there. What it does is you can just go and create a Watson assistant which creates conversational interfaces, and you can also detect visual things. So your Watson assistant will recognize, your visual recognition tool will recognize color, shape, size, etc. of the object, and these are readily available. You no need to bother about your code from the scratch. Suppose you wish to uh, launch a robot kind of a thing which can recognize, which has a visual recognition capabilities, and it has to convert speech to text because it has to understand, and again text to speech, and again it has to speak back to us. So it will convert its text to speech again and uh, speaks back to us. Not only that, and Watson assistants will also provide a platform for language conversion. It can work upon with different languages. We have something called as language translator here. See this language translator. So using this language translator, you can translate the languages and then going back. So AI driven platform is already made readily available. And then Watson Studio, which it can it's a AI and machine learning platform again. So you can custom your machine learning models here using Watson Studio. So let us go and look into this Watson Studio for now. And one more thing here is, I'll go to services. So here catalog displays only few of these things, and these are the all the services provided by IBM Watson. You have compute, again containers, networking, storage. So if you are good at your basic, uh, if you are good at your basic knowledge of any cloud, then you can understand all other clouds because all the services provided are more or less similar. Maybe only the terminology and how they look and feel will vary. So we have compute, containers, networking, storage, AI, machine learning again. And here one more thing with this IBM is they have been partnered with Node-RED, and Node-RED is such a easy language, and rather than calling it as a language, say Node-RED app. Yeah, Node-RED app is there. The Node-RED app is there. So it is such a easy language. You just drag and drop. You no need to bother about how to programming. If you are not good at programming skills, you no need to bother about uh, uh, such things. So when you move to IBM, there is Node-RED readily available. So how this Node-RED works, you just drag and drop, and you can run your Node-RED on IBM Cloud itself. And you can also convert it into Node.js flat code again. So going back to catalog again, Watson Studio, right? And we have machine learning, which is IBM Watson machine learning makes smarter decisions, solve tough problems. So this one such tool is there, and we have a Watson Studio here. Let us go and look into Watson Studio here. And here it asks to select a region, say keep it as London only. The rest of the thing you don't need to bother about your pricing plan because you're on light free. So if for some reason if you want to upgrade, if you want to work on the real time serious applications, you can go and change your pricing plan to standard V1 or enterprise V2, and then I can give name my service. So I'll say keep it as is Watson Studio NY, or I'll say Watson Studio Test and why. Also existing light plan. You can have only one light plan instance. Seems like I already have an instance. Okay, catalog services. Go to IBM Cloud here. On my dashboard, I'll go to view all. Here are 9 services created, one storage. Watson Studio N7 is there here. So let me click on that. So here it is, the Watson Studio platform which I have already created. Let us click on get started. And next, close this. So here we have our Watson Studio. This is my recent project. Predict buying behavior with ML. Click on this. So add a new project. Let us add a new project. So data notebook again here. It gives you all of these things, auto AI experiment, or if you want to work with visual recognition. As I said, IBM offers you a AI-driven platform like visual recognition, which classify images and detects objects. And you have natural language classifier, which classifies your language into textual content, and decision optimization. All these things are there. Let us say notebook. See, it asks me to select the Python framework. We'll stick with Python 3.7 only, and let's say it's my ML notebook. Create. So what we are actually doing here is we are setting up an environment to build our model. So the procedure is same. If you observe in AWS, Azure, IBM, so there are notebook and AWS calls those things as instances, notebook instances. And here IBM, again we have created and repeated notebook here, and we can start working here on this page. And going back to the one which I have already created. Mm. So here are my assets, data assets. So these assets are stored in my storage in the IBM. So this is my data set. So go sales tx base. So this is a .csv file. It has all these things. What they have bought in a store related to some sales transactions. What they have bought, product line. And going back here, and so if you want to work upon with on your assets, then you can always upload your data sets to the storage available on IBM, and here you have to use them. So select this one, asset is selected, and there are two notebooks which I have created. This one just a blank one which I have created, and other one which uses Spark and Python to predict equipment purchase. So this is my model actually. And again we have environments, jobs, access control, and other things here. So this is the platform provided by IBM for analytics. And not only that, and so the IBM has been like very interactive and very simple to coming up with some AI driven applications, as we have looked into all these things. And one more best thing is there is no trial period for IBM. It will not ask for your credit cards, nothing. Just go and you can experiment with IBM as long as you want. So these are walk through all these analytical platforms provided by these clouds. So having said that, I'm concluding the session. Before that, let me ask you guys if there are any doubts. So if you want to know more about all these cloud computing platforms, so you can, if you want to know about machine learning on the cloud, we have ML on cloud, and we have cloud computing a course where we cover Azure, AWS, and GCP clouds, and also you can get an IBM certificate. So if you go through the IBM exam, we give you some assistance, and you can pay for certification and can go through the IBM exam and get a certificate for that. So Muhammad Folk has asked, can you elaborate more about the main use of cloud system? What role it plays today's society? Actually, today's online society, so-called online society, is actually built on cloud, I would say. So when you say online, when you are ordering food online, you are using cloud. Servers are there on the cloud. So that restaurant will don't actually maintain that all the infrastructure, build an application. They will just go and hire a guy who will create an application online portal on the cloud. And the same thing, healthcare, everything has become online today. So if you are doing something online, whether it's shopping or storing some data of your pics of you on the internet, or if you are connecting a video conference call with your friend, actually you are accessing some servers. All these things are happening through servers. You are connecting to some server. Your computer has nothing to do with it. You have to just install some software. For few things, you don't need that also. So actually, you're connecting to some server, right? And getting all these things done. If it is a restaurant, you're connecting to restaurant server where they tell you about all their products and accept your order, etc. And if it is an online conference, Zoom, you are connecting to Zoom server or Microsoft servers. So where actually they are? So they are on cloud. Cloud is nothing but a huge, very huge data center where all these servers will be there. So rather than you maintaining those servers, you go and just buy services from them and you will pay for that. Right? And why we need to learn cloud computing? How to develop such applications on the cloud? How to set up a server on the cloud? Right? How you know all these things? So suppose you are doing analysis, building some prediction model, how you are doing that. So all of such things. When you learn cloud, you'll get to know about that. Cloud computing is emerging technology which tells you to how to build such application using its services. Right? And any more doubts, guys? So algorithm necessary to code machine use. Yes, algorithms are necessary, and the best thing is on the cloud, algorithms are available. The popular algorithms are already available. You can get them and customize it. So half of your work is done. You don't need to bother about pre-processing your data, building your algorithm from scratch. They are already available, and AutoML has been becoming very popular in recent times. So where you just choose your algorithm, which is ready-madely available, and with few changes, your job will get done. Okay, guys. Hope you all enjoyed the session. So please visit our page and to know more about. If you like the session, if you want to know more about cloud computing or other emerging technologies like data science, um, or IoT, cloud computing, again, you can visit our YouTube channel. So whether this video is uploaded in YouTube channel, yes, it might be available on the YouTube channel also. You can go and check there. And we are also offering this IBM certificate, so you can pay for certificate and get IBM certificate by enrolling. And for further details, you can call 360DigiTMG on how to apply and on further details. Okay, guys, nice meeting you all. Hope you all enjoyed this session. Good luck for you guys. Bye.